Okay, welcome back, ladies and gentlemen. Good to see you all. There's a couple announcements that I want to start off with right off the bat. So there's an announcement posted on Quarkus about our upcoming quiz. So tutorials start next week. Every tutorial we have a quiz. This is a sort of a special week in that it's the first one of the course. So we're going to look at your calculus background, okay? So see if you've got the integration and differentiation skills that we need for the course. It often happens that about a third of the way through, someone says, oh crap, we need antiderivatives. This quiz has antiderivatives. So please write the quiz and the tutorial that you're enrolled in. Go to tutorial like normal. The TA will take up some problems, do some review, and then in the last part of tutorial there'll be a quiz. We've got 11 weeks of quizzes, only the best 9 count. Okay, so if you are sick or your car breaks down or you ride the shuttle bus and it's always late and you miss your quiz, then that's okay. That's totally fine. You don't need to submit a medical note, you don't need to do anything. We only count the best 9 out of 11, okay? Won't count against you. Okay? The quiz is going to cover derivatives and antiderivatives. Comprehensive, so expect, integration by parts, integration by substitution, trigonometric integrals. There's a sample quiz on Quarkus, so if you look at what that looks like, something like this. So this is a model. If you go to tutorial 0107, it'll say tutorial 0107, and then it'll have the TA's name, which is a model, so it has my name. You'll calculate the derivative. Okay. The next question, you'll calculate an antiderivative. Okay. Antiderivative sine cubed. Okay. There's going to be part marks available. So each question is graded out of 4 marks. 4 means you got it perfect. 4 means we could publish it in a textbook. 0 means you had no idea. Okay. Nothing. Okay. Questions or thoughts about upcoming quiz? Yes? Exactly 2. It's exactly like this model. Yeah. Yeah.
How long will the quiz take?
So you'll have a half hour. So it's the last half of tutorial. Yeah. Okay. Yeah. Hopefully you'll be able to do this very quickly. Yeah. Hopefully. Yeah. Hello. Welcome. The news is that we have a quiz next week. Okay. The quiz covers derivatives and antiderivatives. Any other thoughts, comments, questions about quiz? So take the weekend, brush up on derivatives and antiderivatives. You're probably already golden, you probably have this. Okay, excellent. Okay, so we talked a little bit about the notion of parametric equations. I want to start doing calculus with them. I want to start showing you what they are useful for, the kinds of things that we can do with parametric equations that are hard to do with Cartesian equations. Okay, so we're still in this section of parametric equations. Were there any questions that came up from trying those assigned questions? Sure, yeah. Oh, just no idea. Okay, no idea. That's fine. Yeah, we can talk. Which specific question was with? All?
Just 40.
Oh, just 49. Okay, yeah, we can look at 49. Yeah. So, was there anyone else who struggled with 49? Question 49. Yeah, it's hard, right? It's a hard question. Okay, so let's give a look at question 49, see what that question looks like. So, we go table of contents, parametric. Okay. So, when I refer to a specific question on the board, I'll write it like this. So we are in section 1.1, and we're looking at question 49. Okay, so this is a capital Q for question. So we want to convince ourselves that this represents a circle. Right, so we want to somehow come up with some evidence that this is a circle in some way. Doesn't look very circly to me. So if I were solving this problem, I would try it out just to get a picture of what's going on. Like I would plot this to get a picture, check if it's circly, and that might convince me of something. Okay, so if I was looking at this, I'd say, well, let's actually put in some numbers and see what happens to this equation. So what's a good value for h? Sure, let's say h is 1. Yeah. Okay. Value for k. What should we pick for k? What's a nice number?
1. 1.
Okay, we'll also pick 1. Okay. Can I get a value for r?
5.
Sure, why not 5? Yeah, great. Okay, so now I will graph this with these values, and we'll see what comes up when we graph this. Hopefully we get something very circly. Okay. Go into Desmos. To graph things, to graph parametric equations in Desmos, we write them as brackets like this, so the xy coordinates. Plus 5 cos t, 1 plus 5 t. Okay, the sort of fundamental domain of sine and cosine is 2 pi, right? If we know between 0 and 2 pi, then we're good. Ooh, looks pretty circly. Okay, so I'm getting convinced that this is circly. Radius makes it kind of hard to see where exactly this circle is centered. So I'm going to make the radius much smaller and see whereabouts this thing is centered. tiny circle. Maybe that was too small. Aha. So it looks, where does it look like it's centered? 1, 1. Okay, so our guess is that what should this circle be? Okay. Don't shout out all at once now. Contain yourselves. Okay, could I get a show of hands? Someone who can say something about this circle. Right here.
It's centered around HK.
Yeah, it's centered at HK. Okay, so okay. Other thoughts about this circle? Yep.
R is the radius.
R is the radius. Okay, nice. So now we've got a pretty accurate description of this circle. It's centered at HK and has radius R. We got that by playing around on Desmos. My sort of feeling about this course is that you could learn much more by playing with Desmos than by listening to me. I encourage you to skip class and play with Desmos. All right, so now we've got a thing to prove. We've got to prove that this is centered at HK and has radius R. Okay, so we've now run out of board space, of course. Actually, one last thing. What's the usual way of writing down the equation for a circle like this? Cartesian way.
X squared plus y squared equals r.
Okay. Where's this circle centered? 0, 0, yeah? So now we want to be centered at HK. How do we modify to get centered at HK? Yeah? Do you have an idea? No? Okay. Yeah, here?
So like when you're moving something, you want to subtract like h or k from.
Yes, good. Okay, so we want to see that this parametric equation satisfies the usual definition of a circle centered at that place. Excellent. So let's try that out. Okay, so we played with some numbers. We got some properties from Desmos or from our visual imagination. Now we've got a theorem to prove. Okay, so what we'll do is we'll take these coordinates, plug them into that equation. If we get r squared, then we have a circle. Okay, so we've got our left-hand side. We'll do algebra until we get our right-hand side. So we take our parametric equation, we plug in A bit more algebra. Just a bit of a check. For people in the front row, can you still see this? You got it? Okay. I'm gonna try and not go past this line because then it's hard to see here. Okay, cool. So what happens next? Yes?
Identity just equals one.
Yeah, that's just equal to 1. Nice. Okay. Right, so our left-hand side algebraically worked out to our right-hand side. Sweet. So for every value of a parameter, we live on a circle. We can say which circle it is. Does that help? That's good. Okay, for people who tried 49, does that help? Yes, great. Yes, thumbs up. Okay, excellent. Are there last thoughts before we go on to the calculus of these things?